Hi, and thank you for reviewing my work. This is Diego Souza speaking, and this is my final project for CSCA 5622, Introduction to Machine Learning, Supervised Learning, with University of Colorado Boulder. The idea of this project and the goal is to showcase the techniques we've all learned during the course, the lectures, and all the exercises, and at the end produce in my case, two different models, one for regression and one for classification. The regression one will be predicting something called ESG score. ESG stands for Environmental, Social, and Governance. And this is a score of a quote unquote how green a company is, if you will. And it's pretty much, in my case here, based on the carbon footprint of the company. Second task is a classification one when we are trying to bucket a company into a particular category of risk or ESG risk. Um, the dataset, as an overview of the dataset, it contains 251 rows and 57 columns, and they are all over the place, not normalized, and many are empty, completely empty. And on top of that, we have the two target variables that we want to predict. They are inexistent. So I had to create these two, and this is what I did in the next step of the exploratory data analysis. So before we even think about creating a model and start coding, we all learned that we have to do exploratory data analysis. And in my case, even further, even before I started doing the exploratory data analysis, I had to create the two target variables. So I created the ESG score and the ESG risk. As my peer reviewer, you have access to my GitHub repository as well as a Jupyter notebook. So please feel free to refer that to see all the calculations and all the math behind that. Um, Basically, for the score, I utilize the scope 1 plus 2 and the revenues with GHG and carbon footprint. After calculating that, I needed to normalize it between 0 and 100 because it is a percentage. And the risk category is based on the SG score and goes from low all the way to high. Here's some statistics of the score distribution and the risk distribution. And uh, we see here in the figure on this plot, we have a very big tail to the left hand side, and that's not ideal. Ideally, we will have something in the format of a bell curve. That'll be ideal. But because this is far from ideal, we have to do an additional step, and we all learned that in the course as well, which is logarithm transformation. Um, so after I applied logarithm transformation, this is some statistics. Please feel free to pause the presentation. I have to zoom it uh, for brevity. The plot here is not the ideal still, but it kind of looks like the bell curve. So I'm less concerned of it right now. So proceeding. Next step is for feature engineering. I spent 5 rounds at least dropping columns. So from all the way to eliminating time series features that we are not interested in, that I am not interested in this project, all the way to removing all not a number columns. For example, the real 01 was not a number, so I had to remove that. So from the 57 features that we started the data set with, we ended up with a final set of features, only 3 features plus the 2 target variables, quite small. As for the models utilizing this project, I started with a simplistic decision tree, and this will be my baseline. And then I dived all the way to the ensemble models, the random forest, the ADA boost, and the XGBoost. This one we didn't learn that much in the course, but during my lecture, during my studies, I stumbled on some books mentioning the XGBoost, and I thought it was interesting to apply here, and why not? So I did. Next step, well, the next model, support vector machine, just because it's non-tree, non-assemble for comparison only. Uh, Now we have to train. We all learned how to train, to split the train and test data sets and shuffle them. This is nothing new for any of us. So in my case, I have two models. I have to split 80-20 in the first one for regression, in 80-20 the second one for classification. Feel free to check my repository to see the actual code. This is just a snippet. And of course, you can pause the presentation at any time and examine it. As far as evaluation metrics go, for regression, I utilize the R square for fitness, RMSE, and the MAE. So I'm not inventing the wheel here. This is what we all learned during the course. For classification, I based pretty much on the F1 score and indirectly using the precision and recall and having as well the accuracy more or less for untying. All right, so this is how my models look after the first fit. Those are all untuned models. So the best one, the random forest, a tree-based ensemble performing a 71% fitness. This is the RMSE 12 and MIE 7. And the worst one, SVM, which is very computational and CPU expensive, scores only 12%, so it's not a fit at all. It's way better to flip a coin than to trust in this particular model for this task. As far as classification goes, XGBoost was the best one, with an accuracy of 70% and F1 score of 69%. SVM, a little less better than a random coin flip. Next slide will show some graphics and visualizations on the best model for regression, the best model for classification, the worst model for regression, and the worst model for classification. So here are the scatter plots, and here are the confusion matrices. All right, so now the fun part, we go all the way to the tuning of the hyperparameters. And those are all the ranges that I use, and this is pretty much free. Uh, it's, in my opinion, this is the part where it is more a art than a science. So, of course, we have some boundaries, but to find the ideal parameters, you have to experiment. That was a lot of fun. Feel free to pause the presentation and look at the numbers. Special attention to the number of combinations that random forest had. So for the regression, this is the big number, 12K, and for classification, 36K. SVM, well, it's not much, but it took a fair amount of time to process. Moving forward, we all learned about grid search CV, and that was the technique that I utilized during hyperparameter tuning to search and cross-validate all the models. And after tuning, those are the best performer ones. Ada boost for regression, these hyperparameters, and for the classification model, XGBoost with these metrics and these parameters. The worst one, SVM, for the regression. And that was a surprise to me. The worst one for classification is AdaBoost. You can see there's almost a tie with AdaBoost and SVM. If I had to choose between AdaBoost or SVM, despite of them the disparity here, I would choose AdaBoost because SVM is very CPU expensive and takes a long time. So moving forward, we have visualizations here again. The best model after tuning for regression, best model after tuning for classification, the worst one for regression, and the worst one for classification. So as one of the deliverables, we all have to deliver an optimal model. Here I'm delivering two. The AdaBoost with its metrics and its parameters for regression, and the classification side the XGBoost with these metrics and these hyperparameters. Conclusion. What I learned while doing this project. First of all, I had a lot of fun, and that was amazing to apply all the knowledge that I've learned during the process of lectures and exercises and everything. Um, Also, something that I could prove here is the effectiveness of supervised learning in this ESG landscape, if you will. It is my opinion that I met all the deliverable expectations. So I have optimal models. I performed all the analysis. I did all the EDA. I did hyperparameter tuning. I put many graphics and plots and everything. I'm happy with the results. And to me, again, this project or investigation highlights the big potential of this particular types of models in the ESG universe, or the analytics of ESG related stuff. Of course, we know that supervised learning requires label data, and label data is not always easy to achieve. So it is also part of my plans to continue using ESG related data sets in the next modules of the course. So for unsupervised learning and for deep learning as well. So I hope you have enjoyed. I have a couple more slides here. The one is the appendix one where I show some more plots. If you're interested in heat maps, all the references and bibliography, special mention on the dataset that I used for GHG shopper and stakeholder takeover initiatives. I have the owner's authorization to utilize the dataset, and I was part of the developers team that actually created this application called GHG shopper. Again, the bibliography, and I strongly suggest if you didn't read that yet, to pay attention to this machine learning bootcamp. This was the one that drove my attention to the XGBoost. As a bonus section in this presentation, we only have, we all saw that we only had 251 observations in this data set. Well, that's nothing if compared with the numbers of companies across the globe. So a good idea here might be to create some synthetic data. And I did so, and I put together a script. And if you look at my GitHub repository, you see that as an experiment, I created 50,000 roles. Feel free to download the repository and use the synthetic data as you will. Again, I appreciate the time you spent here, and it is about time. Thank you very much.